When you're building a new project or maintaining a current existing project, so for example, if you need to add a new feature and it's a big one and you have a monolith, you could probably ask yourself, do I need a microservice for this? Maybe this is a great opportunity to come out into a microservice. Deciding between microservices and monolith architectures is a big decision, and it should not be taken lightly. Monoliths are great to start with, but are difficult to convert from a monolith to microservice if the monolith was not built in this mind concept. Microservices are great at decoupling things. And with decoupling, you move the burden of understanding the cohesive nature of the system from a single from a single place, which is the monolith, into a distributed. So you can think of it as really separate entities, and in addition you have the premium to pay. You need now to pay in operational cost of maintaining all these microservices. Both, of course, are great architectures, but each one of them should be handled differently. You can reach a very simple monolith architecture if you are a small startup and young, and this would be a great use case for you. It's more difficult to reach this state, but it's possible also on a bigger company. As your project becomes larger, microservices might make more sense, but it's not that the microservice itself, this architecture makes more sense. What makes sense is the solution. So even let's not call it a microservice. Let's say that we have a server, and this server is performing functionality A. For example, it does stock trading. Okay, so we have a server that does stock trading. This is a server that was developed for a few years, and now we would like external users to be able to access it. So we need an API to it, and this is a whole new project. I mean, the accessing stock trading with all its limitations and the security that needs to be involved now that you are an external API and taking care of maybe mobiles that connect. And so, okay, so this is a whole different domain, and you have this big server that does all this in a proper way. Then this can be a good use case for you to create a new service, and we don't need to give it a name, a microservice. Okay, we are simply having a new domain to work on, so we are creating a new service, and it makes a lot of sense because it's quite different from the core of the business, the core of the thing that we are doing. It makes sense for it to be a different domain. It's going to be handled by different people. It's going to be created by a new team, and maybe even in a new language. It makes sense in this sense to create a microservice. It didn't make sense originally to create the whole algo trading as originally as microservices, because if what you try to reach from the beginning, when you create your service, you say, oh, we are going to use all these different languages because we have different people that prefer different programming languages, and also each one with its own style. Hey, why don't we just have microservices environment? Let anyone do with whatever programming language they want, with whatever design patterns with what they want, with whatever code formatting they want, with whatever logging they want, and it's great. It's microservices. 2 pizza teams. No, so this is not the argument. The 2 pizza team and each one can use its own language and its own formatting, because if they are doing it on all these teams are doing it on the monolith, then they are messing it up. So this is not a good argument because you have just externalized the mess into the microservices and incurred also the premium of the operational burden. So we have seen an example that we have a stock trading app, and we have seen when it could be a good use case. It would be actually a good use case to externalize it into a microservice, not necessarily, but it could be a good use case, and when it's not a good use case. One of the problems with this argument of microservices versus monoliths is that it's not considering the third best option. And the third best option I would call the modular monolith. The modular monolith is a well-architected monolith, and it can really be a joy to work on. So I would say it's not a debate between the monolith and the microservices. It's a debate between the monolith and the microservices, and I didn't know that I could also do this with the modular monolith. Because usually you are taken to the extreme. I'm going to do microservices, I'm going to do a monolith, but what about the modular monolith, the well-architected monolith? When we think of the microservice architecture, we tend to think of, hey, look at how simple this microservice is going to be. It's going to be a 2-pizza size service. It's so simple. It's now going to be a whole of a distributed system. But in many cases, what's happening is that you end up with a distributed monolith. And a distributed monolith is much worse because you have just taken pieces of your monolith and extracted them into microservices with no well decided upon boundary in between the services. You have a distributed monolith if what you see as a side effect or as a smell is that you're duplicating your data in between the microservices without transforming the actual data. So if you see that you have the same data residing in multiple databases, because it was said that each microservice should have its own database, and you have the same data without actually transforming it, this is a sign that you have a distributed monolith and not an actual real microservice. You can think of microservices in that way as separate companies. In separate companies, usually you do have different data, or it's not the same. Okay, it's not exactly the same data. You have your cleaner, you have your different developers, you have your different systems. Also, if what you see is that your one service cannot work without having service B or C up, then this is also not really a microservices. You are in a big mess, okay? If one service cannot work without the other services or without specific service B or C, it's a distributed monolith. You've taken your monolith, and when a call fails, you didn't take into account what happens in this place. What you could do is, in these cases, you should take into account, in the case of a microservice, what happens or what do I do if the other service is down, or increase its or decrease its probability of being down. You need to invest time in it. And you need to decide what happens if I didn't get a response. Another indication that you're not having a real microservice architecture is if you try to keep all your services in sync with some kind of a global event bus. If you thought that Kafka and similar event buses are there to solve all your microservices problems, then keeping all these microservices in sync is a little bit crazy, because you need to listen to all those events, and then you have all these operational complexity of what happened if I missed the event, what happened if the server was down. It's a really big trade-off, and then you start looking at event sourcing, and you say, okay, I have this Kafka, so I will do event sourcing, and if one of my microservices was down, then I would replay everything. But for how much long in the past should you replay everything? If you need to replay it for a too long of a period, you'll find it's taking too much time. So this should be taken into account. It's possible to implement this successfully, but we need to take into account all the operational burden and all the event sourcing that is taking place and all the complexity that we have traded off. This is why I'm a strong proponent of the modular monolith. Okay? Because in the modular monolith, in many cases, which is suitable to many cases, is not suitable to all cases, but in many cases it's suitable and it does the job perfectly. And in the modular monolith, another benefit is that we do not ignore problems, because if we started by separating into microservices only to allow different teams to work on the specific services, also called the two-pizza team, then we could have architected our monolith so that different team could work on it and have it on the same code base and everything. And I'm not mixing up with the monocode versus multicode. It's an inherent part of having the single monolith, that single code base that I could download and work on, and I could see actually the flow of the calls. So yes, there are times to distribute into microservices. It makes a lot of sense, but we need to invest a lot of effort in the operational burden. It's definitely not a free lunch, not close to even a big time paid lunch. It's a really huge effort. You're moving the effort from the code, from the developers into an operational one, into whoever is doing the operational stuff, which is also the developers. In the microservices, you need to see that if you see that someone that is handling the project is not owner of the data, he's not the owner of the model. He is not the owner of the permissions, of the domain, of the boundaries to this microservice. Then this is again a sign that you're not really having a microservice architecture. You have taken your monolith and split it in a way that is not allowing each team to focus and be the owners of the whole security, of the whole model, of the whole data of the service. This brings us again to the idiom of microservices is like different companies. The more we think about it like this, the better we are able to split into microservices. Because when we think of different companies, we know they own their data, they own their model, they own the permissions, and it's take a while to get into them and out of them, and they own their release cycle. It's a different company. This is the best way to think about it. So microservices are good. They just should be handled carefully, and also a modular monolith is good and also should be handled carefully, also with clear bounds in between the modules. I think that the most critical thing when either splitting into a modular monolith or microservices is to draw the boundaries correctly. If the boundaries are creating too small services with too many interdependencies and they don't encapsulate really the data, we end up with too many interdependencies, and we don't want to get into this. Okay, we want the dependencies to be clear. We want to know exactly what happened if we called another service and we couldn't, if it's okay at all. If it's not okay, how do we handle this? And there is simply not enough, because this topic is not so formalized. then it's not an equation. It's not a mathematical thing. It's not a program. It's something that people think about and decide how to do it. And a very special care should be handled into how you connect those things. Once you've split into the microservices, then it's very important to see that the different microservices are doing each of its own domain. They are like split vertically. Okay, it's not mixing up from the domain of one service into another. And Kafka and the event bus and Kubernetes won't solve it for you. They can help, but they will surely not solve. If the original concept of the boundaries in between the domains is not correct, then there would be a big mess. It's very risky. The best thing to think about also in multi-moduled monolith and in microservices is the boundaries between the services. It should be vertical. And the trouble is that when you go into microservices, you start introducing, you understand that you need some communication between the services. And when each service is calling each one, it's becoming like an interconnected system. And then you are drawn into solutions like Kafka and Kinesis. And this solution do provide you with some kind of event bus and event sourcing, but event sourcing is difficult to implement. With event sourcing, you have like the truth, but in order to reach the truth, you have to replay everything, and it's hard to implement in practice. You would need to replay all the business events. It could be a month of business events, and it would become difficult not to talk about transactional activity. Transactional activity would become super increasingly difficult when you become into microservices, and you might drop it and use some kind of a different system. And it's going to become complex. So I would stick with the modular monolith unless you are really big, unless you can think of it, as we said, as different companies. If you can actually think, and it makes sense for the different teams to be different companies. If I would take your company and break it into multiple companies, and you would tell me, okay, so now I have a secretary for each company, and I have a cleaner for each company, and I have the developers, and I have the operational, and I have the managers and the CEO of each company, and it would make sense, then it makes sense for this to be a microservice. Okay, but this microservice would come with a secretary, with the CEO, with everything, if it makes sense. And of course, you wouldn't split something into a separate microservice or a separate company if you think it's highly correlated to another service. Okay, because in this way, you can make sure that you are not making your microservices too small. Okay, it should be the right size of the company. If you split your microservices vertically, then it could be very beneficial. But if you split them horizontally, because you didn't think about how it's actually different companies, it could be problematic. So when you think about when you have reached a state and you're sure that you need to break your monolith or build a microservices environment, then you need to think now about the storage, how you save things. And when you think about the storage and how you save things, who are the consumers of the storage? One of the big parts of the consumers that you should be taking care of at the beginning is the reporting. The reporting is like a separate team. They are trying to understand what's happening in the system. And now that there is not like a cohesive place to search for the stuff, their job has just become increasingly difficult. Now you're telling them, instead of doing reporting on my company, you have 200 companies to do a joint reporting upon. Now go and meet with those 200 companies and I want to see an end-to-end report. This is extremely difficult. Okay, this is extremely difficult and painful and expensive. So we should think about how the reporting should behave when we split into microservices ahead. Usually what happens is that the use case, I'm not sure there is a good solution for this, but many of the things that we discussed here do not have an optimal solution. It's just things that you need to do at place. Then in this case of the reporting, what generally you could do is like take all the events and push them into one big data lake. This is why the data lakes have spawned up in the recent years. It's specifically because of this reason, because what happened is that people split their services into multi-services, and now the reporting guys are trying to deduce what's happening in the system. So all the Microsoft services said, okay, so we are going to stream all the events into one big data lake, and you, the reporting guys, you have there all the data. Just go to the data lake and extract the data for your reporting. And then the reporting guys would go into this data lake and extract the data into some more SQL-ish like place, because analytics on a data lake where you just throw your data is not going to happen. So you take all this data and you push it into an SQL-ish like some kind of Postgres SQL, something like this, and you do all the analytics all on this. This is one of the main reasons why the data lakes have spawned up in the recent years in order to allow this kind of reporting. Another reason why people might move into a microservices environment is because the deployments are too hard. You see that you have hundreds of commits every day happening. You see that one commit is breaking all the teams when you try to deploy it. You see that rollbacks are painful. You see that the deployment itself is taking too long. It's like taking too long, and you have a shutdown of your service and you need to take care of your multi-module monolith. So then you say that, okay, I would need to break this into a microservice. So at this point, I would say again, while you could break it into a microservice, let's think of the pros and cons. If we break it into a microservice, we would have all this operational burden. It would be good if we do it well. It would take a long time. We would have all this operational cost. It would be a really huge operational cost, but there is another option. It's the modular code with the different artifacts that you deploy. This can be also challenging, but it's less challenging than the microservices. And also you are gaining from it the ability to share the data, to have one cohesive place to look at, and it can actually be a joy to work on. A modular monolith can be a real joy to a developer. Imagine a developer getting into a new company. Now imagine that he has many microservices which he is not even aware of. Okay, it's not really exciting. He can work on his specific team, on his specific feature, but once he needs something from another team, this is a process, okay, and we want to move fast. With a monolith, non-well-designed monolith, this can also be some kind of a hell, because you would just not know what's the effect of changing one character. You could change one character and the whole system would explode 2 months ahead. In a well-designed modular monolith, the developer would come, he will see different modules in the monolith. He would know that if he changes something in a specific module, it's like he's changing something in a specific microservice. He would know that if he runs the whole test suite for the monolith, then everything is fine. Okay, so this is why the multi-monolith, the module monolith, can be a real joy to work on. And this would be my choice in many of the architectures. And then of course we could spawn up some microservices, do it very carefully, do a well-designed multi-moduled project base, span out the microservices where needed, for example, for API services, and for some basic services, and this could actually work and utilize the new tools that we have in order to make this all easy. So I think this was pretty interesting, and I will see you the next time.